Great. I think go with the question I posted for Marco that was answered in the chat, but I want to make sure those who weren't looking or don't have access to it can hear the answer. I was asking the additional sensitivity that's described in the presentation is citing, and I was wondering how the precision on your measurements improve after the timescales that were quoted in that middle column. So what are the timescales optimized for specific results? And Simona, you can actually take go ahead and discuss that if you'd like.
Okay. Can you hear me?
Yep.
Yes, so that is a good question. The results which were showed by Marco Muccino, the timescales refer specifically to the results shown in the middle column, which we will achieve in the short mid-term. So it's a matter of a few years and up to a decade. Then in order to reach the ultimate goal, which is doing laser ranging with an accuracy below 1 millimeter, so improving also the other general relativity measurements, will take more than 1 decade, and will take two things, basically. Synergism with geophysical measurements to be done with a full suite of geophysical instruments like the laser reflector and mainly the seismometer. These kind of measurements are foreseen by future missions to establish a global lunar geophysical network, and there is a specific announcement opportunity of NASA for which it will be done a proposal led by Clavinio, René Weber, and an international national collaboration. So that will investigate and understand better the details of the interior of the moon. Those are useful also to test general relativity. The second aspect is, of course, the improvement related to statistics. So the larger the n number of measurements, 1 over square root of n will improve, but the systematics will come from the lunar geophysical network. So I think Clive is in the audience, so if he can comment on this, it would be perhaps useful.
So if there are additional comments, we're open now. Nelly, if you have questions or anything else you wanted to bring up. If anybody does have additional questions, you can also use the raise hand function. So let's see. So there's a question
to you.
Yeah, sorry, I don't find the raise hand button. That's why I just typed it.
Go ahead, Sebastian.
Yeah, okay. So I just take the liberty to ask this quickly here. Prabal, you mentioned this low mass, right? And okay, when you say when I saw the less than 1 kg, that's of course for somebody who just went through the design of a entire science system, which is far less than 1 kilogram. It's kind of like a hefty bucket to carry if I think about taking something like this along and rovers in the foreseeable future. Personally, I don't think we're going to get for the next 10 years beyond, you know, much more than 10, 20, 50 kilos or so. What's from your experience, I think that's how I phrased it. So when your current experiments, what's the lowest mass sample you considered sensible or reasonable or useful?
Yeah, absolutely. So I think that's, and that 1 kilogram quote is definitely on the heavy side. I know that, I know there are plenty of systems engineers who look at that and they scratch their head at how that's, how it's light. But I think in this case, when you look at some of the processes we're targeting, so for example, kind of water transport and hydration, some of this like charged particle effects, these other things, they can be done on the substrates themselves are going to be very, very thin. So we're talking literally like for the actual specific substrate plates in the region of micrograms. So then it really comes down to the actual design of whatever that biscuit is in terms of holding these separate substrate sections. And that's something we're working on right now. We're optimizing that. So I think even less, we're talking in the tens to hundreds of grams, but that's something we're still looking at. So that's something that I think as we start to determine how to optimize this for a specific measurement at a specific place for certain processes, there's going to be some give and take on that. So that's something that we're working on designing now, but I can't give you an exact quote on the number. I can give you kind of the substrates themselves are not going to be the driving factors. So.
Okay, no, that's fine. That's fine. I was just seeing this 1 kilogram on your slides, and that kind of like caused some shivers. But it's fine. So that's what I was expecting. The actual samples will be extremely lightweight. Yeah. Thank you.
Is there any other question, comment, opinion? We have the luxury of having a little bit of time, so don't hesitate.
I know that Seichi actually leads. So if you have questions on that talk, you can email at the email that was listed in the chat. I'm sure Leva was a transcript as well at the end. I don't have any additional questions. I actually went through the questions I had as well. Nelly?
No, not for me either. I think the presentations were very, very well made and very clear.
So I guess what we can do is we can wait another minute or so. If anybody does have a hand they want to raise, or they have a question that comes to them, put it in the chat and raise your hand. Otherwise, I think we can kind of end earlier than the suggested full hour and 50 minutes.
Yes, I would agree. One last round of questions. It's difficult to read the body language, isn't it? So we don't really know if there is any question coming. So we don't have to shake the raised hand.
But there should be a thinking but not quite there yet button for
Yeah, yeah. I will have one in a minute.
I think otherwise, thank you to all the speakers. Like Nelly said, really clear talks and really interesting material. Kind of capping a really great week of talks as well.
Good. Well, I guess that's it. Thank you very much, and thank you to all the participants. So we appreciate that we are one of the last sessions of the last day. So so it definitely is a great effort of you all to be here. So thank you very much, and thank you to the speakers.
Thanks, everyone.